Welcome. This is William Witcher, and this is CYB604. This is the Wireless and Mobile Security course. My project is called the Witcher Rouge AP project. How many public Wi-Fi hotspots are there out there? There are literally millions of them. As you can see from this particular chart from iPass, and this is an interactive map. If you'd like to go to this particular URL, you can see the same items in real time. There's been an explosion of Wi-Fi hotspots over the past 3 to 4 to 5 years. And you can see here the growth from 2013 is up 271%. Drilling just a little bit deeper, let's take a look at who the leaders are in Wi-Fi hotspots. By country, France is way ahead. 13 million public Wi-Fi hotspots. The US is second with just under 10 million, and then we have the UK, China, Japan, Netherlands, etc. In North America alone, since 2013, 2,521% is the growth from 2013. My opinion here is that public Wi-Fi hotspots can be both an ally and an enemy to your personal data. So always proceed with caution. Remember, you are the first line of defense to your personal data. Looking further here at Wi-Fi hotspots and consumer expectations. There's a quote here from the New York Times. These days, travelers are accustomed to free Wi-Fi nearly everywhere, airports, fast food, etc. Another quote here from Wyland Pros. The fastest connection I've ever received at a hotel was free service, very inexpensive Motel 8. The gentleman noted that he got close to 100 megabits. That's extremely fast. Hopefully that connection was legitimate. When did you last use a public Wi-Fi hotspot? Getting coffee somewhere? Maybe you're at a concert. You want to capture that great show. How about at a ball game? Maybe in a stadium full of people. You want to be connected in real time to your sports stats. Perhaps you're on a fantasy league. Maybe at a hockey game. I want to get that goal. Capture it. Maybe even been at a political event. I want to make sure you capture this for your children and your children's children, sort of thing. In this scene here, I've created a fictitious scenario. We're going to call this the CYB Motel. It's a beautifully restored 5-bedroom Victorian home located in Stone City, California. It's located near the airport. The CYB Motel advertises around the airport quite heavily. And guests stay on average 1 or 2 nights, so there's always a quick return. The typical guest is a high-end business traveler looking to stay in a unique Victorian home setting. The CYB Motel provides guest Wi-Fi access to its customers, and the Wi-Fi is managed by a family friend. The guest, however, and here's the plot. The guest at the Wi-Fi, at the CYB Motel, can get solid, secure internet service, WPA2, AES level. However, the motel has a narrow parking lot next to it, and the rooms face this narrow parking lot. Directly adjacent to this parking lot is a 2-story apartment complex. Guests at the CYB Motel, in scanning for a Wi-Fi signal, get a low to medium signal. It's the real signal, but it just happens to be kind of weak. However, guests, while also scanning, can receive a very high to strong signal from another AP access point called the Free Wi-Fi Stone City. And security standards are high as well. Given the poorly configured system, guests who stay at the motel routinely connect to the Wi-Fi Stone City connection. And it's an unfortunate choice. How they connect to it is a bit secure. Well, in today's world, malicious hackers are being a bit more sophisticated. It doesn't take much for people today you stay at a hotel, people are sliding things under your door, whether it's a menu for the Chinese restaurant, takeout or pizza or dry cleaning, and there's always various flyers and whatnot sitting on the information desk down at the hotel, right in the lobby. And a lot of times vendors just come in and drop them off and leave. This is sort of a subtle way of getting people attached to your particular system. So in this case, we're just using the assumption that that scenario has been successful and that the malicious hacker has already provided the ability to saturate the area with flyers noting the free Wi-Fi Stone City AP, and he's already given out the password for it. So you can connect anytime you're ready. My tools for this project: Windows 8 laptop. The business system is going to be a Dell laptop, standard business system, running Windows 7. And we also have a Linksys router here. Typical router you can pick up at Best Buy, 802.11n, which is, for the most part, the majority of users today. Although AC is out, a lot of users have not yet transitioned to that. And a lot of users have moved on from B and G, and now they're on N, 802.11n. Another tool I'm going to use is called My Public Wi-Fi version 5.1. It's going to be the Wi-Fi share tool that I will use to create the Rouge AP. Another package I will use is Wireshark, packet capture. Another application I will be using is called NetWitness Investigator, PE. It's an RSA product now, legitimate. It's got full forensic tools associated with it, and is a package that can be used when collecting forensic level evidence, meaning you're collecting the information, you can forensically put a hash on it to ensure that it can be legally submitted in a court of law. So in some cases, this might be an indication where you're trying to, let's say, capture the bad guy and ensure that your evidence is legally acceptable. My process. The process is going to be to launch the public Wi-Fi, start, get captures going, and then stop the packet capture, then review the packet capture, and then open a new project in NetWitness and review it further, and then save the file for evidence. My process demo is going to take us through the process and kind of walk us through the point-by-point in which I will set up the public Wi-Fi item, configure it appropriately, and then ensure it starts. You can see from 1 to 2 to 3. I will then show you the interface that has been established on the, let's say, the target machine. I would say the source machine, the machine in which I will be capturing the packets. Also show you that this interface is alive. It's got internet access. It's got an IP. It's ready to go. Also in this process demo, we're going to walk you through the capture that's going to be taking place here on NetWitness as well. So we'll set up the project, we'll make sure it's configured, and we will connect to the particular interface and begin additional capturing of packets. We'll then launch Wireshark. We'll take a look at Wireshark, begin its capture of traffic, and we will also then analyze that traffic as well. Process demo will also include additional aspects here of taking a look at what else we have been able to capture. Further capture information. Before we go into countermeasures, I'm going to pause this video and then start the demo. Okay, we're going to pick up where we left off here by launching our demo. I will begin launching My Public Wi-Fi. Okay, we'll take a look at the settings here. Looks like we're set there. The Wi-Fi looks like it's been launched. It's set. Our key is Stone City. No client at this point. Show URL logging. In this process, this is where it's going to be. Okay, so we're going to enable logging on that process. Okay, so that should be all set. Okay, next we're going to take a look here at our actual interface to ensure that our interface is actually up and running. Let's go on out here to our interfaces here, change adapter settings. Let's take a look. As we can see, the interface has begun. This is free Wi-Fi Stone City. As you can see, it does have internet access, and it's ready to go. Let's further take a look at the IP information as we were showing in the PowerPoint. Take a look at details here, and as you can see right now, it does have an IP address. Okay, so it's in the .137 class subnet, and that's what we'll be looking for in our packet capture. Okay, so we'll go ahead and close this for now, and we'll close this as well. Okay, now next we're going to make sure we bring up the packet capture item. Let's bring up Wireshark here. Let's identify the particular interface, and let's do a start on that. Okay, now that's launched. We're also going to take a look at NetWindows Investigator. We'll run that package as well. Okay, let's start a new scenario here. Let's take a look at configuring the unit. Okay, we're going to capture not on acrylic, but we're going to capture it on the G-bit controller here. Should be the right controller. Let's just double check. Yes, it says. Okay, let's see. Okay, there. All right, and then we're going to go ahead and start. All right. So right now it's connecting, and it says it's ready, so it's capturing. All right, let's minimize this at this point. Now let's go over to our virtual machine, and let's see if we can get that going. We'll make a connection here. Connect to it. I'm going to call it Stone City, and we're going to connect. Okay, take a look at what just started happening here. You see that? It's happening on the screen? That is the live capture from that other machine. We're actually going to go out to a website here as well. Bringing up the website. A little slow, but that's fine. Anyway, let's just go out to CNN.com. Breaking news. Okay, here comes CNN. All right. Yeah, look at those packets coming through loud and clear. How about that? All right, folks, that's the demo. That is showing us we definitely are having packet capture. Let's go on out to, say we're going out to, I don't know, let's go out to ESPN. Okay, ESPN as well. Those packets are alive and kicking right there. How about that? So this just shows you that this individual actually is connecting to a AP. They did it in a secure way, and they believe they are doing just fine from a surfing standpoint on the internet. However, there's a man in the middle. And in the middle is this particular box we're looking at now that's capturing all those packets. Thank you. I will now stop my packet capture here. Make sure I save it. Okay. We'll call this project. We've done a demo before, but this is the second demo, and we're actually going to make this a PCAP file. By the way, a PCAP file, and we're going to call this one number 2.